videos are not just videos. Every few minutes, the video pauses and the students get asked a question.
Prospect theory, hyperbolic discounting, status quo bias, base rate bias, they're all well documented. So they're all well documented deviations from rational behavior.
So here the video pauses and the student types in the answer into the box and submits. Obviously they weren't paying attention. So they get to try again. And this time they got it right. There's an optional explanation if they want. And now the video moves on to the next part of the lecture. This is a kind of simple question that I, as an instructor, might ask in class. But when I ask that kind of a question in class, 80% of the students are still scribbling the last thing I said. 15% are zoned out on Facebook. And then there's a smarty pants in the front row who blurts out the answer before anyone else has had a chance to think about it. And I, as the instructor, am terribly gratified that somebody actually knew the answer. And so the lecture moves on before really most of the students have even noticed that a question had been asked. Here, every single student has to engage with the material. Now, of course, these simple retrieval questions are not the end of the story. One needs to build in much more meaningful practice questions, and one also needs to provide the students with feedback on those questions. Now, how do you grade the work of 100,000 students if you do not have 10,000 TAs? The answer is you need to use technology to do it for you. Now, fortunately, technology has come a long way, and we can now grade a range of interesting types of homework. In addition to multiple choice and the kinds of short answer questions that you saw in the video, we can also grade mathematical expressions as well as mathematical derivations. We can grade models, whether it's financial models in a business class or physical models in a science or engineering class. And we can grade some pretty sophisticated programming assignments. So let me show you one that's actually pretty simple but fairly visual. This is from Stanford's Computer Science 101 class, and the student is supposed to color correct that blurry red image. They're typing their program into the browser, and you can see they didn't get it quite right. Lady Liberty is still seasick. And so the student tries again, and now they got it right, and they're told that, and they can move on to the next assignment. This ability to interact actively with the material and be told when you're right or wrong is really essential to student learning. Now, of course, we cannot yet grade the range of work that one needs for all courses. Specifically, what's lacking is the kind of critical thinking work that is so essential in such disciplines as the humanities, the social sciences, business, and others. So we tried to convince, for example, some of our humanities faculty that multiple choice was not such a bad strategy. That didn't go over really well. So we had to come up with a different solution. And the solution we ended up using is peer grading. It turns out that previous studies show, like this one by Sadler and Good, that peer grading is a surprisingly effective strategy for providing reproducible grades. It was tried only in small classes, but there it showed, for example, that the student assigned grade on the y-axis are actually very well correlated with the teacher assigned grade on the x-axis. What's even more surprising is that self-grades, where the student grade their own work critically, so long as you incentivize them properly so they can't give themselves a perfect score, are actually even better correlated with the teacher grades. And so this is an effective strategy that can be used for grading at scale, and is also a useful learning strategy for the students because they actually learn from the experience. So we now have the largest peer grading pipeline ever devised, where tens of thousands of students are grading each other's work, and quite successfully, I have to say. But this is not just about students sitting alone in their living room working through problems. Around each one of our courses, a community of students had formed, a global community of people around a shared intellectual endeavor. What you see here is a self-generated map from students in our Princeton Sociology 101 course, where they have put themselves in a world map, and you can really see the global reach of this kind of effort. Students collaborated in these courses in a variety of different ways. First of all, there was a question and answer form, where students would pose questions and other students would answer those questions. And the really amazing thing is, because there were so many students, it means that even if a student posed a question at 3 o'clock in the morning, somewhere around the world, there would be somebody who was awake and working on the same problem. And so in many of our courses, the median response time for a question on the question and answer form was 22 minutes. Which is not a level of service I have ever offered to my Stanford students. And you can see from the student testimonials that students actually find that because of this large online community, they got to interact with each other in many ways that were deeper than they did in the context of the physical classroom. Students also
Okay, let's pause again. So, what do you learn from the previous video? What do you learn? What do you hear? Anyone want to share? Please raise your hand. Anyone? Anyone? She said something about peer evaluation, the y-axis and x-axis, the teacher's evaluation and the student's evaluation. They are the results are linear, which means the homework delivered, those homework delivered by the students from all over the world. You see, from the professor's view, it is good. From students' view, from the classmates' view, they think it is also good. So they have the linear. How we say that? They have the similar. They have the similar feelings about that homework. If the professor thinks the homework is good, the other classmates also think that homework is good. I try not to use a very difficult word, otherwise you cannot understand me. So the other way is, she said, the student who is in some place, who asks a question, even in 3 a.m. in the morning, some other students in another country who may have the same question, she can discuss with the other students in very different, they may answer the question for those in India or in Taiwan. So people in the United States can answer the question raised by people living in Taiwan. So, for example, she said there is a person who asks a question. Another person will answer the question even at 3 a.m. in the morning, because in the United States maybe 3 a.m. but in Taiwan maybe in morning or in the afternoon we can answer that question. She said the fastest response is 22 minutes. She said herself cannot respond students' question in that short time. So that is basically what I heard. So do you want to share your views? What you have heard from the previous video? No, then we continue. Then after we finish this video, I would like you to discuss with your own group. I would like to know what do you think about this video?
assembled that any kind of intervention from us into small study groups. Some of these were physical study groups along geographical constraints and met on a weekly basis to work through problem sets. This is the San Francisco study group, but there were ones all over the world. Others were virtual study groups, sometimes along language lines or along cultural lines. And at the bottom left there, you see our multicultural universal study group, where people explicitly wanted to connect with people from other cultures. There's some tremendous opportunities to be had from this kind of framework. The first is that it has the potential of giving us a completely unprecedented look into understanding human learning. Because the data that we can collect here is unique. You can collect every click, every homework submission, every forum post from tens of thousands of students. So you can turn the study of human learning from the hypothesis-driven mode to the data-driven mode, a transformation that, for example, has revolutionized biology. You can use these data to understand fundamental questions, like what are good learning strategies that are effective versus ones that are not. And in the context of particular courses, you can ask questions like, what are some of the misconceptions that are more common, and how do we help students fix them? So here's an example of that, also from Andrew's machine learning class. This is a distribution of wrong answers to one of Andrew's assignments. The answers happen to be pairs of numbers, so you can draw them on this two-dimensional plot. Each of the little crosses that you see is a different wrong answer. The big cross at the top left is where 2,000 students gave the exact same wrong answer. Now, if 2 students in a class of 100 give the same wrong answer, you would never notice. But when 2,000 students give the same wrong answer, it's kind of hard to miss. So Andrew and his students went in and looked at some of those assignments, understood the root cause of the misconception, and then they produced a targeted error message that would be provided to every student whose answer fell into that bucket. Which means that students who made that same mistake would now get personalized feedback telling them how to fix their misconception much more effectively. So this personalization is something that one can then build by having the virtue of large numbers. Personalization is perhaps one of the biggest opportunities here as well, because it provides us with the potential of solving a 30-year-old problem. Educational researcher Benjamin Bloom in 1984 posed what's called the 2 sigma problem, which he observed by studying 3 populations. The first is the population that's studied in a lecture-based classroom. The second is a population of students that studied using a standard lecture-based classroom, but with a mastery-based approach, so that students couldn't move on to the next topic before demonstrating mastery of the previous one. And finally, there was a population of students that were taught in a one-on-one instruction using a tutor.
I believe I have to explain a little bit. Lecture-based means I give a lecture, student just sits on the desk, they cannot move, that is lecture style. But mastery learning means students cannot move on until before they solve some questions. If they have to answer some questions correctly, then they can move, which means mastery learning. Individual tutoring means one teacher and one student. I teach, just very private, one by one or one-to-one or one-on-one, which means individual. One teacher to one student. That kind of learning. This kind of learning achievement score is the best, which is called 2 sigma problem. 2 sigma. Okay.